Okay, so now I want to actually look at using Sympy. So let's say we want to have an example where we find the zeros of a quadratic function. So let's say, I don't know, so we can have a subheading here, finding roots of quadratic functions, and we can say, let's look at the function p of x equals x squared plus x minus 6. And we want to find the solutions to p of x equals 0. These are called the roots. Okay, so there's two solutions. First, note that we can factor the polynomial as x minus 2 times x plus 3. So, 2 and minus 3 are the roots. We will also use Sympy. So to get so I wanted to kind of look like a code block. So to get a code, so Sympy is a package, and to get a code block, you do 3 of those, and then 3 of those, and hopefully this is going to look kind of like a code package. It's going to look okay. See, it's sort of got Sympy with gray around it, so it's not a code package, but a code block. Okay. Anyways, I'm not saying this is the best way to explain what we're doing here. If you're doing this for a class, maybe you want to write more. But this is just an example here. Okay, so now here I'm going to use Sympy. And to start off, I'm going to do import Sympy as SP. And then all of the sort of functions and variables within Sympy, we're going to have to do sp dot something. And you can look, again, I think on my, if you go to my webpage, I linked to my webpage to my differential equations class. If you go there and look at the second set of the second sort of row on the list of things, that second row of stuff has a document where I teach how to use Sympy, and so you can use Sympy, and you can also use Professor Manuel's videos as well. Anyways, so I'm just gonna go over some basic things here. To begin with, let's see how we can use Sympy to solve algebraic equations. So for example, we need to introduce symbolic variables. So we're going to let x be a symbolic variable. So we're going to say x is equal to sp dot symbol, then give this the label x, or we're going to make it the variable x. So x is a computer variable. It's a variable in Python that is storing the symbolic variable called x. And so now I'm going to say p is going to be equal to this polynomial. So p is going to be x squared. So when I do x squared, it's not x caret 2, it's x star star squared. This means x squared in Python plus x minus 6. And now what I want to do is I want to build an equation. So there's a number of ways to do this next step, but the Sympy library has something called equations, and then it has something called solve, and it knows how to solve equations. So I'm going to begin by saying EQ is equal to SP dot EQ, and then you just put the left-hand side of the equation and the right-hand side of the equation. So the left-hand side of the equation is x squared plus x minus 6, and the right-hand side of the equation is 0. So now, like stored within Sympy is the equation x squared plus x minus 6 is equal to 0, where x is a symbolic variable. Okay, so if I run this, you're not going to see any output unless I've made a mistake somewhere. And luckily, I haven't. And now what I want to do is I'm going to say solution is equal to sp.solve. And you're going to tell it what you want to solve. So you're going to give it the equation EQ, and you tell it which variable you want it to solve for. So for example, we want to solve this for x. So now, hopefully when I run this, there's not going to be a problem. We're still not going to be able to see anything yet. Okay, and now, let's say I want to print the solution. We're going to get this. Okay, so minus 3 and 2 are the solutions, which is what we know it should be from up here. We can also do this in multivariables as well. So let's say I want to just add a y. So let's say I want to do y is equal to sp.symbol. And now let's say I want to do plus y. Okay, and so now everything's going to run the same, except the equation is going to be x squared plus x minus 6 plus y is equal to 0. And we want to solve this for x and y. And so what happens is the following. These are going to be the different values for y. So y could be equal to x, or y could be equal to this thing. It could be equal to minus x squared minus 6, or minus x plus 6, which is just, the negation of this. Okay, so the solution then is x is equal to x. That's what this first component says. And y is equal to minus x squared plus x plus 6. Obviously, this doesn't give a lot of information, but that's, this is the type of equation we have. It's one equation in two unknowns. So one of the variables is going to be defined in terms of the other one. Okay, so this is it for algebraic equations. In the next video, I'm going to show how we can use Sympy to solve differential equations.